Hello, everybody, and welcome back to CoMotion Labs Fundamentals for Hardware Startups. I'm Brady Ryan, the CoMotion Labs Hardware Manager. If you joined us before, and I'm sure you have, then you know that CoMotion Labs is University of Washington's effort around startup incubation. We operate 3 incubators here on campus, one for hardware, one for life sciences, and one for software. We don't take equity in our startups. We don't take any of your IP. We just want to help our startups succeed. Here in the hardware incubator, we have a bunch of 3D printers, including both resin and FDM printing, a whole circuitry solder setup, a reflow oven, CNC, laser cutter, and a ton of tools. We also added a vinyl cutter this week, and we are building a injection molder. So always building out new capabilities in here. We also have relationships across campus with all the machine shops and 3D printing shops. So if you need something that we don't have, we probably know somebody who does. We also recently installed a 5G network in our space with millimeter wave, ultra wideband, and narrowband 5G. So we're ready to start working with innovators in the 5G space, doing advanced sensors, edge computing, that sort of thing. We have one bench available for another startup to move in. So if anybody is looking for a home, let me know. While we wait for everybody to join us, I'll make a few quick announcements. Next week, our last event of the hardware series, we'll be hearing from Jim Brismivitz, founder and general partner at 5G Open Innovation Lab. Jim will be presenting 5G fundamentals for entrepreneurs. All of our fundamentals for startups presentations are archived on our CoMotion website under innovation training videos. We've covered a ton of topics, so check that out if you have any time. For our full schedule of events and to register for future fundamentals, you can visit our website, CoMotionLabs.com, and click on the fundamentals link. You can also subscribe here on YouTube and click the bell so you'll know about future live streams. And lastly, Fundamentals for Startups is funded in part by a grant from the Economic Development Agency. We'll be dropping a link in the survey or a link in the chat rather to a quick survey. If you could fill that out, we'd really appreciate it. Today, Aaron Kaiser is here to present Trends in Hardware Development and Entrepreneurship. Aaron is the CEO and co-founder of Igor Institute, a product development and hardware engineering firm located here in Seattle. As a strategic marketing and communications business professional, Aaron has led teams of talented people that are committed to enhancing companies' unique brands and helping to redefine the conversation around product development, hardware engineering, device design, healthcare, and higher education. Aaron will take all questions via the YouTube chat. Feel free to throw questions in there, and he's given me permission to interrupt him during his presentation, so don't be shy. And I will now turn the event over to Aaron.
Thank you, Brady, and thank you, CoMotion, for the opportunity to join you guys today. We'll be talking about trends in hardware development entrepreneurship, really just some of the things that we have experienced here at Igor Institute over the last couple of years and see developing into a larger segments of the industry over the next few. Even though many people consider the Seattle area a software hub, there has been a long history of entrepreneurship, hardware development, and manufacturing here in the Pacific Northwest. Boeing, for instance, started in 1916 and over the decades spurred a massive third-party industry around fabrication, design, and development, as well as a large diaspora of hardware engineers who went on to work at places like Fluke, Microsoft, Philips, and become entrepreneurs themselves, joining places like CoMotion. So when Brady approached me to develop something to present, I decided to focus on the discussion around the emerging industries and trends that we see, and further how this awareness of these verticals and trends help hardware teams realize success, whether that is with funding and where funding is going into right now, collaboration, and going to market. And I apologize if there's a little bit of noise. I'm right on the street of Pioneer Square, First and Main, so it gets a little rowdy around here. So as Brady said, I'm the CEO and co-founder of Igor Institute, which we started 9 years ago this month, with a focus on specifically to establish a deeply senior team of hardware engineers with experience taking complex products to market. A little bit about Igor Institute. We're a 35-person hardware product development consultancy. We've got people in offices in Seattle, San Francisco, and Vancouver, BC, but have team members in a handful of other locations as it has the new norm of a distributed team. But our headquarters are here in Pioneer Square in downtown Seattle, and the collective team is mechanical engineers, electrical engineers, firmware and embedded engineers, program and project managers that get brought in to help engineering and support the manufacturing of consumer electronics, connected IoT platforms and devices, and some medical devices here and there. Generally, 80% of our work is in the consumer space or a consumer-driven platform. So as you can see on the slide, these are some of the clients that we've worked with throughout the years. About half of our clients are large, notable consumer brands and platforms, and the other half are emerging startups with a wide variety of technical applications. As a majority of our work is a consumer focus or requires ergonomic and human factors considerations, we work with many of the top industrial and UX UI design firms locally and around the country as well. And many of the work that we've done that would be on our website has been in collaboration with design firms in the Bay Area, Seattle, and East Coast. So, talking about trends and opportunities in hardware, I want to begin to touch base on the hardware verticals that we have seen the most growth in over the last, let's say, 18 to 24 months, and see growth continuing based on our conversations that we've been having over the last few months. The most clients, these are where the areas of the most clients have been emerging in the last 2 years for us and prospective partners that we're in discussions with now. This list is agnostic of the technologies or platforms that enable them, which we will talk about in a bit. This is just a quick set of examples of the types of hardware-focused solutions we at Igor Institute have experienced recently. And I apologize in advance, as this might be kind of a rambling set of loosely connected thoughts and ideas. So any one of these areas, especially climate-related technologies, could use their own hour of discussion. So what we've seen, the area with the most interest recently, especially in the last 24 months, has been in climate-related technologies or applications. And I've lumped electric vehicle and battery technologies into this, as from a funding perspective, those areas make up the bulk of climate-related venture funding or private equity funding, with some estimates that about 2/3 of climate-related tech funding goes to mobility and transport technologies alone. So this vertical also includes battery technology and battery management systems, right? So firstly, carbon removal and sequestration is an increasingly well-funded area of hardware and technology development. As the carbon capture market continues to grow, we also see the need for continued growth in the carbon transport and storage industry. Long-term sinking of the removed carbon is probably the most Wild West part of the climate market right now, on top of carbon credit market. The question being is what to do with the removed carbon as to not release it for many, many, many years, right? And there are a few approaches that we have worked on and seen explored in earnest in the last 18 to 24 months. So it is feasible to take carbon from direct air capture or other methodologies and encapsulate it, or through a chemical process create carbon solids, and then bury it or use it as an additive to materials like soil and or cement. So this has the benefit of helping agricultural health in the first instance, or ocean health, for example, and mitigation by using maybe a cement-based 3D printed reef structures to increase habitat areas in shallow waters or dead zones, or creating breakwater and bulkhead structures to combat sea level rise and storm surges. So, using the stored carbon in a cement application, not just for building or foundations, right, or sort of general construction, but using it to also increase habitat and increase the amount of carbon uptake in the ocean, right? So ocean health and carbon sequestration can also be jointly beneficial, right? So there's other technologies that we've worked on, some of it with some folks out of the University of Washington, like artificial upwelling, which can bring iron-rich cold water to the ocean surface, which increases zooplankton and phytoplankton, and which in turn brings a feeder fish in, and so on and so forth, restoring fishery habitats. And that's if deployed in large scale, right? You have to think of 60-foot diameter ocean buoys that are bringing cold water up from about 100 meters below. But it's also sinking carbon because fish waste sinks to the bottom. And moreover, artificial upwelling, for example, and with some caveats around filtration of nutrients, could be used to cool coral reefs, for example, or if deployed behind drones or electric tugs, theoretically be used to decrease sea surface temperatures in areas in front of storm systems, possibly lowering a storm by a category if deployed in large scale.
What's the name of a company doing that? This is Brady, obviously.
Yeah.
You, I think. I would love to look that up. That sounds fascinating.
Yeah, in fact, I believe there's some ex-FOSS folks who are exploring that, right? There's, it's not necessarily a carbon sequestration technology, but it is there's billions of dollars per level of storm, right?
Mm-hmm.
If you lowered it by one level, you'd save billions of dollars in damages, right? And habitat loss, et cetera. And habitat in the ocean creates carbon sequestration, right? So the healthier the oceans, the more carbon it sinks. It's the largest carbon sink in the world. 2/3 of the world's carbon are sunk by ocean alone. And so the healthier the ocean is, the better we can address reduction of carbon emissions, right? Or at least combat carbon emissions, not reduce.
I took a 1-quarter class about marine biology, so I'm something of an expert. So hearing about artificial upwelling, it's very exciting. So I'll look them up.
Yeah, I mean, the real challenges to any technology, but whether it be terrestrial carbon sequestration or ocean carbon sequestration, is regulatory. Ocean having the most regulatory bodies within a given body of water. It's some areas of the near shore or non-pelagic waters could have 7 different regulatory agencies that need to sign off on any sort of deployment of technology in the ocean. So it's a difficult hardware space to be in without the right amount of funding and government support, but it could be increasingly the largest area of gains in sinking carbon. Right?
Are you working with Marine Blue at all? The incubator that I think it's the Port of Seattle is putting on, that's kind of around maritime technologies.
Yeah, we've talked to them. They're definitely focused in ways to decrease shipping, logistics, and port emissions, right? And that can be anything from hydrogen-powered vessels or salt reactor-powered vessels, or any sort of electrification of tugs and shipping methodologies, right? It'd be fun to work on. Those are large-scale projects, and I think it's really early on sort of identifying how to implement those. But yeah, it's nice to see that's happening more and more, seeing as that Seattle is one of the largest ports on the West Coast, right? You've got Long Beach, Tacoma, and Seattle as the 3 biggest. Right? So there are other ways to address water and ocean health, and I apologize for talking about climate so much. I also am part of a group called Aquabetic Labs that is specifically trying to figure out ways to use hardware-enabled technologies to improve ocean health, but more importantly, sequester carbon. So it's something of a passion that I have, and something that the folks at Igor enjoy working on, right? There's other ways to that ocean health that are not necessarily sinking carbon, but reducing the impact of habitat, increasing the amount of carbon that's not retained by the ocean, right? And so, for example, HABs, or harmful algae blooms, could potentially be mitigated with exposure to certain wavelengths of light instead of chemicals. We currently address them. If you think of the Gulf Coast of Florida, they will go out there and spray them with chemicals, which is harmful to the habitat and actually decreases the amount of life in the area, which then just in turn increases the amount of harmful algae blooms over time. So when eradicated, they allow the natural process of carbon sequestration to become, continue, in a healthy body of water. So going back to mobility and specifically battery technology, and getting off climate for a bit, we've seen a growth in custom battery management, right? As more and more things become electrified with batteries, and that's everything from electric vehicles to solar farms that need to store the energy. We're seeing custom battery management technology explode across more than just electric vehicles, right? So companies and universities, for instance, we've worked with one of these companies that are working on fusion technology reactors, are in parallel developing their own battery management systems and monetizing that work currently to help pay for the ongoing R&D for fusion reactors, right? So currently with energy storage partners, or even EV companies, with the goal of eventually using their battery management technology to kickstart their reactor down the road, because it requires about the power of a small town to boot up, right? So they're already ahead. They've almost got two companies within one. They've got their fusion reactor company, but they're also trying to create their own battery management systems to do that, right? So we're seeing a lot of movement in that. Battery management health is intrinsic to that battery system. So managing battery platforms from vehicles to solar farms is evolving to have more efficiency in maintaining battery life and battery health at the cell level, the battery cell level, as opposed to the current standards of multiple cells bundled together into one brick. And if one cell fails within that brick, the whole brick needs to be replaced. Having a system that can take that battery cell offline within that brick and continue to use that power management system without full replacement, as the materials to make batteries become more and more scarce over time. And finally, a very small segment, but interesting trend, is consumer contributions to climate health and/or consumer products that are more sustainable. To slow down, or in a perfect world, reverse climate change, it will take an enormous amount of government and industry efforts to make a dent. However, awareness of the populace is still an important part of the solution. Consumer awareness, let's say, albeit a small amount of physical impact. It can create large waves of pressure for change to happen. And we've worked with teams who are revolutionizing food production with lab-grown seafood or meat, direct air or harvest, harvesting carbon, right? And then if you direct air water harvesting for homes. So think a dehumidifier with a water purifier on it. So you put this appliance, hopefully it's powered by clean energy, and it pulls moisture out of the air and serves you delicious drinking water or cooking water. So applications in developing worlds, as well as applications domestically, right? And of course, home solar systems. All those examples of consumer-driven products that have a small impact on climate health, but are really about creating opportunities for people to participate in reduction of carbon emissions, right? And then finally, or further, right, more product companies are looking for ways to decrease their carbon footprint from the materials they use, the packaging the devices come in, and how to manage end of life and recycling. There's a company locally owned by Cal McAllister called Loca, which is, for example, is using, trying to work with us to develop 100% compostable dry erase marker and kids markers, which you would think would be a pretty easy task. It's not a very intelligent device. It's got 3 or 4 parts to it. It's surprisingly more difficult than any of us would have imagined 2 years ago as we started this process, because finding the materials to do so don't exist. And most of the materials that make things like this are made overseas. And we had to spend a lot of time over the last 18 months convincing manufacturers of these parts and pieces of markers and systems to try new materials, to try different pulps, to try different compostable tips and caps that would make this possible. So, finding low cost manufacturers to make these products, because it's a low margin device or product, that are willing to take a risk in trying something new has been difficult. The second area of increased growth are in IoT. IoT is everything, right? I mean, it's sort of an ubiquitous term, but IoT applications at the government, industry, and agricultural placements or levels, right? So as cities and municipalities become smarter, the use of connected hardware to monitor resources and predict events has increased tremendously over the last few years. And we think it'll continue as populations increase, the effects of climate change are more severe, and resources become scarcer. One example is a local company who might have been connected to CoMotion at one point, Storm Sensor. Their long distance monitoring platform is deployed directly into sewer and stormwater systems, deployed across entire cities, measuring temperature, flow rate, direction, and depth. And it gives municipalities predictive data and utility managers information on flooding and overflow events, mitigation opportunities, and reporting requirements when these events happen. This is just an example of how connected hardware has left the home and is being used. The same is true as has been for a while in warehouses, factory floors, logistics services, and shipping as well. In the next few years, solutions will continue to be required to support supply chains and manufacturing. The tracking of assets and items throughout the supply chain is an increasing area of investment and technology application. Not only do consumers, companies, and shipping agencies want real-time data on the location and status of an item, but insurance companies are increasingly interested in the historical status as well. Of course they are. Insurance losses for misplaced, stolen, or damaged items are in the billions per year in the US alone, and that is driving innovations in low-cost, low-energy tracking solutions that hopefully aren't a complete landfill additive as well. And then in agriculture, not only is connectivity increasing, but the analysis of the data and use of it for better practices is too. We've seen, a lot of technology around camera systems, nurseries, grow houses, and farms, using those to detect disease, nutrient deficiencies, dehydration in real time, allowing for higher yields, better crops, and less loss. And going forward, there's additional applications in agricultural needs that can be addressed, like nitrate and nitrite runoff from farming operations could, for example, be detected and automatically filtered at the local level before entering water systems. In areas with increased drought measurement or water management could be addressed with sensor communication systems. And we're already seeing some of that in the canals in Central Valley in California, capping them for solar power, but also mitigating evaporation and measuring the water quality.
Couple questions for you, Aaron, on this IoT, on the IoT space. First, we were at an event, 5G Open Innovation Lab hosted their big launch, and I remember you were talking about not making sure that sensors don't just become more landfill all the time. And I remember you felt that very strongly. I'd love for you to talk about that and kind of what maybe our responsibilities are, thinking about now that we have the ability to sense, should we? Right. And then the second question is, if you can help put this in the context of 5G, with 5G coming online, do you see that as something that really matters? And maybe a brief preview for next week. What is 5G going to mean for innovators? You don't have to necessarily define it.
I'll have you ask me the 5G question in a moment again,
okay,
because I have that as part of a thought process later in the presentation. But the first question about sensors, and I think we did have a very passionate discussion about the throwaway nature of many IoT devices, especially the ones that are supposed to be trackers, right? And so FedEx has a tracking system, and because it was developed by FedEx, they can reuse it. They have a system in which they can bring it back on board the truck and recycle it, recharge it, or replace the coin cell battery or something, right? There are other companies though that are just trying to make disposable sensors that have a battery in them, have an antenna, have an accelerometer in them, have some sort of cellular or Wi-Fi or Bluetooth connected device, all of which they expect to be thrown away after you open up your package. And I don't know if you're like me, Brady, but I get a lot of packages from the internet. And so we actually, I mean, I wouldn't mention who they are, but we actually declined to work with them because they didn't have an end of life solution on what they would do with the millions and millions of sensors that they wanted to develop. Also, I don't know if it's yet feasible to get the sort of communication and battery life that they expected from something that small. But when challenged about its end of life and recyclability, they were not interested in exploring that. And so, hopefully more and more sustainability minded deployable sensor systems and companies will be developed.
I think that's remarkable that you guys turned down that work. I think I said that last time we talked about it, but props.
Yeah, every once in a while we actually say no to business. Right. And so sorry, I had those bullets on both slides, but and finally for this initial topic, we're seeing a huge amount of growth in what I'm calling, or what we're calling prosumer wearables or e-health products. So an explosion of like electronic health products. So electronic health being able to measure and then influence body function using a device that is non-invasive and is not, shocking you or anything like that, but just as a way to sort of help support an ailment of some sort. So we've seen it continue to grow. Many of these devices are right on the edge of prescriptive or status changing technologies, right? So if you prescribe something or you change the status of a body, you're not just measuring biometric data, but you're enacting with the body. They are requiring FDA approval, even though they're non-invasive. And as part of entering the market, that increases the complexity of their development and the development time. So the biggest area that we've seen within this is sleep technologies. And it probably has the highest amount of potential consumer adoption initially. For example, there's companies exploring the ability to measure brain waves while someone is ready for bed, and then using audio feedback specifically to the user to slowly transition them to a theta wave state, which increases their ability to fall asleep without the use of a supplement or prescriptive medication. Of course, the technology will be connected to an app and the cloud instance providing data to the user about their sleep patterns and data, and then to the company around the aggregate efficacy of their product. As well in sleep, we've also seen people trying to do biometric measurement in real time to prevent hot flashes or mitigate hot flashes while in sleep for women with menopause, and being able to predict within seconds the oncoming of a hot flash, and then using a cooling pad to cool the body to keep them in sleep. So one of the biggest issues when having hot flashes is that you get disruptive sleep, right? So you're not well rested. It's like being woken up every couple hours. So that's a company out of Boston that's working on that, and it's pretty exciting. Just the in-time, real-time measurement that reactive. So other examples of e-health products that we've seen recently would be the ways to detect long-term diseases like Alzheimer's. So the lymphatic system is a system in your brain that removes toxins while you sleep, and as it degrades over time, it's a predictor of the onset of Alzheimer's or early onset Alzheimer's. And so there are ways to measure that using a wearable that can then give you the data, or your doctor or healthcare team the data they need to understand and prescribe activities or other things that might help mitigate the onset or hold off the onset of Alzheimer's. And then I'm sure people have heard of different companies trying to do this. We've worked with a couple here and there. The holy grail of wearable technology is the non-invasive measurement of things like glucose in the bloodstream or cancerous cells. You're using RF technology instead of a blood test or a finger prick. There are companies that have been funded and gone out of business trying to chase this down. But a lot of them are actually pretty close to market and are probably functional and in clinical stages or testing stages right now. So we see a lot of hyper growth in that realm. Think of all the different things that you could measure in your blood that if you did it over time, right, you'd have a better sense of your body's health, and your healthcare team would have access to that.
I think there was a company that got funded and went out of business doing it with a finger prick as well, now that you mentioned it.
Mm-hmm.
Are you seeing any sort of preferences from consumers around whether they have these biometric devices that are just informational for them versus sharing with providers? Are consumers kind of breaking one way that, hey, I want this to be my data that I know about, versus, or like, hey, I want this to actually guide my care and talk to my EHR?
That's a great question, and another thing that we'll talk about in a minute. You're on it today, Brady.
I have not seen his slides, everyone, I promise.
Yeah, but yes, I mean, I think I'll mention again, right, that the onset of increased amount of telehealth over the last couple of years has made that idea of remote sensing and sharing that data more feasible, right? I think something like I saw the other day, maybe 80% of all clinicians provide some form of telehealth now compared to before COVID, which was much smaller than that. So I think we will continue to see more and more of that, doctor approved home measuring systems to allow that bio. In fact, I had a doctor's appointment the other day at telehealth, and he asked what my blood pressure was and my weight, and I was like, I don't know, because I wasn't in the office to get on the scale and get my blood pressure checked and stuff like that. So I think we'll see more of that over time.
Has anyone taken a shot at having a device that Teladoc or whoever sends ahead of time that has the blood pressure and the pulse ox and all that sort of stuff, and so you get this set to you the day before your appointment, and then you send it back, and then they
I haven't seen anything that is specific to the application. I mean, we've seen people try to make a wearable that measures blood pressure, for instance, which is a difficult task, right? Or measure glucose through the skin, right? But nothing that's holistically, or at least we've seen holistically around, let's collect your data. You could have one for the whole family, right? Let's collect your data and send it to the doctor for your telehealth medicine meeting, right? And so maybe insurance companies and or healthcare providers or HMOs will eventually provide something like that, sort of a home care kit. A lot of those medical devices, though, have to be calibrated and are highly susceptible to decline over time, right? And so there's all of that, right? And again, if you're taking that information and it's prescriptive of any kind, then FDA, of course, it's a medical device, right? Yeah. So again, on this slide, a lot of these topics could be a complete presentation on their own, so I won't go into any depth in any given one. But these are the technologies and industry trends that are worth noting for their impact on hardware development, right? So we talked about some of the verticals within hardware devices. And these are sort of the technologies that are driving a lot of innovation right now. We're seeing a lot of industries using generative design, and specifically the automotive industry has been the most successful in terms of its use in innovation of new components, right? Using machine learning and AI, automotive manufacturers can simulate in less than a day what weeks of physical testing would provide in a design of a new part. So take, for instance, like a seatbelt bracket, where the goal is to make it stronger and lighter than the original concept. Using 3D models with an established set of requirements allows software designers or software to design a component that a human may not have been able to think of. Using machine learning, this allows for continual testing and validation before any product is physically manufactured and put to test, right? And this ties into additive manufacturing or 3D printing. There's a huge explosion in the mass adoption of additive printing as a way to actually put product into market, not just a prototyping tool. So not just used for quick turn proof of concepts, but manufacturers and companies are increasingly using additive manufacturing for actual product production. So it decreases the cost of tooling and capital expenditures, speeds up time to the market, and it's not just polymer, right, as the medium to use. It's metals for automotive and silicone for medical uses that are already in products now that are on the market. And then, going back to generative design, additive manufacturing allows parts to be made that would be too complex in shape and material than traditional manufacturing methodologies would allow. So going back to the seatbelt example, the shape of a final seatbelt design might not have been moldable with traditional manufacturing, but with additive printing, they can get it lighter and stronger because it's in a shape or a format that makes it easier to manufacture with additive printing.
So generative design. I had Hans Hanswall, who spoke earlier on this series, was talking about that one time with me. So that is just truly handing over the design of a part to computers, where they can think about it.
Establishing inputs, right? Like strength, environment, and size, and desired weight, and volumetrics, form factor constraints, right? It needs to fit in this cube, and you're allowing AI to just churn through it and come up with a part that matches all those requirements.
I imagine that would be fun to see some of the outputs there, and I bet there's some what would seem ridiculously creative to us, right? The models are able to. They don't have boxes to think in, I guess. Like they have the restraints and the assumptions, and then they can.
Not to say that humans can't think of those things, but tasking someone to come up with 60 versions of something to see what you write is a much different task to go. And this is getting to the cellular thing, Brady. So as we're seeing, as more and more products and sensor systems require data to be shared and analyzed, the cost of communication is becoming more affordable. So setting aside for a moment the requirements for battery life driving a lot of in situ sensor systems, wireless communication across distances is what can enable these systems to be deployed. Currently, creating a product that works on a cellular network, or up until recently, creating a product that works on a cellular network required a complex system of network licensing, monthly costs, and third-party partners. It wasn't just like there are system on chips and modules that have cellular systems on them, but you still have to negotiate contracts for deployment across the network. It was what you would imagine a cellular company would create. However, there are emerging companies that are designing low-cost systems that can be integrated into a product for a flat initial cost that provides an amount of data over time that you're allowed to access and already on the cellular network. So I don't know if anyone knows who Ray Ozzie is. He was at Microsoft for many years. Before that, he was the founder of what became Lotus Notes. And he's got a new company on the East Coast called Blues Wireless, and we've talked to them a few times. And they've got a series of pre-connected cellular modules that are really small and are for low power sensor devices, allowing people to deploy a sensor system on a cellular network worldwide without having to go through the hurdles of getting on a cell network. So it's pretty cool. And then that goes back to 5G. So you have technologies like that, Brady, that are allowing for low cost edge computing and sensor or connectivity via cellular. As the 5G networks expand, right, we'll have more reliability and a larger amount of bandwidth for that. Again, bandwidth comes down to battery life and how much data you're allowed to send on the network based on these pre-made modules. But I think over time we'll see that become cheaper and cheaper.
I just want to check in on one thing. That's the second time you've said something that makes it sound like there's a core trade-off there between battery and the data you can handle. Is that maybe a heuristic that we should adopt?
Yeah, maybe it's just because that's just our pain point every day, right?
Yeah.
Is length of service, size, and data, right? And any of these devices that are not plugged into a wall or running off of an engine have a limited or finite amount of battery life. And so as we make things smaller and smaller ways to harvest energy, RF harvesting is a way to create low energy sensor systems potentially, right? And in certain applications. But yeah, it's just something that it's constantly a problem. It's always has been. I'm sure everyone here charges their phone once a day, right? So but you still want to have all the bells and whistles that the phone provides, right? So it's that balance between size, cost, and connectivity, right? And then, another example of connectivity is the increase in the ability to send and receive data across distances citywide, like citywide RF networks. So many municipalities in the United States and the world, Europe especially, utility cable companies are adding LoRaWAN networks to their citywide networks. This allows product developers a way to collect sensor or location data on a distributed long distance, low power network. Storm Sensor, the company that I mentioned previously, they are using LoRa in their city deployments of their sensor systems. So their underground sensors connect to the lower networks that are deployed in those cities and then transfer that data to the cloud. And depending on the application, LoRa, for instance, outside of a cellular system network, can get pretty long distances. We're talking in the maybe kilometer plus distance, if depending on interference, et cetera. So, for systems in which we're trying to, let's say, sense fire danger across a national forest, could you do it with long distance LoRa, where you have some hubs here and there that are transferring that data into a place where now you have cellular connectivity, right? And then outside of that, we see, especially in consumer products, a lot of consumer personalization. Bless you. Because of the varied ways to manufacture a product, customization of products for the consumer, from skincare formulations to smart apparel, is growing. People want to have a custom thing. Manufacturers or companies want to make a lot of things. So, there's ways to sort of bridge them both. There's a skincare company actually that you can search for on your own that will take a sample of your DNA and will send you a customized formulated face cream specific. I don't know what they're doing, but I would also read the terms of service on their website before you send them in your DNA, because I'm assuming that they also make money selling that information in some way, right? Or maybe not. The artificial intelligence and the Internet of Things. So, that's those new acronyms that keep coming up, right? So there's artificial intelligence in the Internet of Things, AIoT, and then the Internet of Medical Things, right? They're just sort of new acronyms for an increase in the amount of data collected and analyzed, and as a way to measure consumer behavior and product adoption. For instance, you could, your car could automatically order replacement parts for your car before they break down and have them delivered to the shop or delivered to you to replace, knowing and measuring long distance and using AI to kind of predict that, right? And then, for instance, we were talking about telehealth, right? So remote care it would be something that would be also sort of this Internet of Medical Things, right? This device, whatever it was, measures your biometric data. AliveCore is an example of that. They've been around since 2013 or 12, actually. They started off in veterinary care, but it's a two-lead ECG measurement, and that data for a subscription can be analyzed by a cardiologist weekly and can let you know how your heart's doing. And so that's an example of that, right? It's connected to your phone, and then it shoots it up to the cloud, and for a monthly fee, cardiologist will look at your chart and determine how you're doing.
Question there on the Internet of Medical Things. I know that, you have to be aware of security anytime there's IoT happening, and that's why everyone's printers are getting hacked, right? But it must be more important for medical things to be on top of your stuff on the security side. How do you think through that? How do you guide clients through that?
Right. You are nailing all the future things that we're talking
about.
about.
Sorry.
No, that's great. Look at Brady. You're on it. The Internet of Medical Things is complicated. If we talk about it in a clinical setting, hospitals in clinical settings can be at best archaic in their IT deployment and systems, right? So just getting on to a network in a hospital involves a lot of red tape, staff that aren't necessarily trained in providing services like that. We're seeing a lot of medical devices implement cellular connectivity to them to get around the hospital infrastructure required to be on their Wi-Fi network and transfer data securely. Strangely, again, something I was reading the other day that, a higher majority of Internet of Things that are medical devices are unsecure than in consumer devices. Strangely. So that is an area ripe for cybersecurity growth and support, right? And then the last thing is, it feels a little self-serving, but it is definitely something that we've noticed a trend in, and that's the outsourcing of development, right? That could be software or hardware. It's not just sort of offshoring, it's the outsourcing of it from a company perspective that it's becoming considered more of a business process than a necessary internal competency. The small, nimble teams that are funded startups, can either go through the process of spending 6 months to a year trying to hire a team of people to research and develop, or develop a product idea that they already have, or they could get started right away and hit those milestones and get to market faster, right? If you think about the growing of a company first to build a thing, right?
I would love to have you kind of give your pitch and I know you just did to a degree, but I am getting more and more and more and more on board with my companies in the hardware incubator working with product development groups, because it allows them to focus. So whether that happens at the end or now, I would love you to just kind of capture why you have seen it has been worth it for some folks. It's not for everybody all the time, but like why that is such a force multiplier for startups.
Yeah, I think there's a couple reasons. Obviously, outsourcing product development has always existed, right? We came from a company that did it, and the people that started that company came from a company that did it, and it just kind of goes back and back and back. I think, and we'll talk about this in a minute as well, but I think it's becoming a wash as far as financial investment to do it externally or internally. If you think about the type of talent you need to create new and innovative products, and the type of talent requirement or salary requirements that talent can command in today's market, it's not dissimilar from hiring a team that can be brought in, spend 12 months working on something, get it to market, and then leave, right? And maybe at that point, hand it over to a set of internal engineers to sustain, right? So, for instance, a lot of our work with Nike over the years has all been in R&D, right? Where it's better for them to conceptualize, work with us, and then say, hey, can you go try this and see where you get to, and then bring it back, right? So I just think it's becoming less of a, I don't know if it was a pejorative ever, but less of a like, well, I need to do it with my own team. And I think funding has changed a little bit too. If you look back at acquisition trends in software 20 years ago, it was about how many people you had in the office. That was the value of your company, right? You have this many engineers, and so that must mean you're worth, let's say, $350,000 an engineer, right? So it changed your valuation. As software as a service has changed that, hardware as a service has changed that. The product itself is probably driving valuation more than just the amount of bodies.
And another question, what's the breakdown in client engagements where folks come to you for, hey, we need this whole thing, like we need you to develop the whole product, versus, hey, we need help with the case or one sensor or like a sub part of the whole thing?
Yeah, that's a great question. I'd say 2/3 of our work is the entire program, right? At some, and I think 1/3 of our work, R&D might turn into an entire program. So I'd say 1/3 of our work is like, hey, we're stuck. Can you come help us?
Yeah.
Or we've got this solved. We just can't solve this, or we don't have time to. So in parallel, can you work with us, right? So it's a mix. Just the full program is always great, but it's sometimes fun to be called up to try to solve something that someone else hasn't been able to yet, and see if we can. And we don't always do it, but try. Right. So this goes through some challenges, right? This is a very rambling talk, I know, but I want to point out some of the challenges that we have or we've seen in the industry related to the increase in outsourcing product development. But the general reality of the job market, which we just talked about, is that hardware engineers are in high demand. In fact, if any of you are electrical or firmware or mechanical engineers, please reach out to Brady to get my information so we can interview you. The big four, right? So Amazon, Microsoft, Alphabet, and Meta have been in an arms race with benefits and salaries to attract talent over the last few years. And that has meant that smaller, innovative hardware teams are finding it really difficult to attract and retain good talent. And especially in the initial funding and development phase, right? That early startup phase. So we don't see that changing for a while. I don't think I know anyone that owns a company that isn't posting a "we're hiring" sign on LinkedIn every day. That is just a reality that is increasing. And then going back to what we talked about a second ago too, Brady, amazingly high percentage of devices, both home and medical, are susceptible to attacks, or they're running on unsupported operating systems, or a lot of them have most of the data they're sharing to the network is unencrypted, right? And that could be visual data, camera data, right? Audio. And so we see that as this space continues to grow, hardware security and encryption will be an important career or sort of engineering subset that needs to exist as hardware development continues to be more connected, right? I'm sure that Jen Eby spoke about this last week, but component availability and supply chain issues have created an amazing 2 years worth of pain. So we spend a lot of time usually designing for efficiency or cost or performance together, right? In the last years, we've also had to start designing for supply chain. And that is, based on what we can get in the next 52 weeks and in perpetuity, so product can actually be manufactured on time. So we're currently purchasing parts for our clients a year in advance, in some cases, risk buys, before we have even selected a manufacturing partner to work with. And so the component world's a little upside down. Brian Hensley, one of my mechanical engineers, mentioned today that he read an article that, again, I don't have a link to send with you, but every wafer silicon wafer is spoken for through the end of 2023 already. It's insane. And COVID had a heavy hand on the situation, especially when it comes to shipping and logistics and slowdowns during lockdowns of parts manufacturers. But in addition to that, and it's kind of forgotten that Taiwan, the world's largest center of chip manufacturing, experienced a monsoon season prior to COVID with no rain, immediately prior to the outbreak of COVID. And so since chip manufacturing is so highly reliant on water during the fabrication process, the government rationed water to all the manufacturers, and it caused a month's worth of low supply and delays before COVID even hit. And then that just exacerbated all of that slowdown. So what we would normally not think about until we're designing for manufacturability. In some cases, we're now early in the phase and we're still defining the product and doing the product architecture, encouraging our clients to pre-purchase thousands of parts to make their first runs as soon as possible. And I don't want to end this in a down note, but I think it's the least trivial issue affecting hardware, right? And so in this world, right, we've got increasing conflict and suffering from political instability, both internationally and domestically, and in many areas to manufacturing goods like Ukraine, whose people are suffering through a terrible and unjust situation and loss of life. We're the backbone and center of European manufacturing for home appliances technology, shipped all over the world. Both Flex, formerly Flextronics, and Electrolux were projected to manufacture over $100 million worth of home appliances in 2022 alone in Ukraine. And they employed a combined 5,000 employees. And they're just two of 25 different manufacturers that do manufacturing in Ukraine. So obviously human life is much more important than a delay in a new kitchen appliance or other parts of the world. But if other parts of the world, like especially Asia, also become unstable, we'll have to rethink as an industry what is important and how we can support all the partners and humans that are in the product development cycle. So we're, I think all consumers and people around the world are feeling not only sorrow for what's happening in Ukraine, but it's going to impact us for years and years and years to come in ways that we don't quite know yet from a hardware standpoint and software standpoint. Brilliant engineers also. So anyhow, any questions you have? Happy to talk about it. That was it.
Perfect. We're getting some questions in the chat. Please feel free to keep adding those. A couple questions that have already come through. Dan, one of our members here in Hardware Hall, asks, can you speak on ocean-bound plastics? How suitable are they for high-quality injection molding parts?
Oh, that's a great question. How to start that answer? They're collectible, right? The problem with ocean-bound plastics is how to sort them, right? Because not all plastics can be recycled into injection moldable plastics. Right?
Can you define ocean-bound plastics?
Plastics found floating in the ocean, and that can be all the way down to microplastics if you could filter them, right? Which would be an excellent thing to do, which would take pretty serious amounts of energy and membranes to do so, but it's possible. There are some water filtration technologies that, if done in the right way, could at large scale filter out microplastics. But I'm assuming that the question also involves just the amount of plastics in the ocean. Yes, so if collected, which is an extremely energy intensive thing to do because you have to go out into the ocean to do that. If you could sort it, you could use it for recycled plastics. I'd posit that another way to so the answer is yes. Another way to reduce ocean plastics, it's 8 of the world's largest rivers that contribute 99% of the plastic to the oceans, right? So it's not people throwing a plastic bottle over their pleasure boat or from city runoff, but it's rivers like the Nile, the Ganges, right, the Mississippi, that are dumping an exorbitant amount of plastics in the ocean each day. And technologies, I think there was a Dutch company that tried to do this, and I don't know how adopted it was, but technologies at the mouth or the delta of a river that could filter and remove plastics before it enters the ocean would be an instant change to the amount of debris in the ocean in a few months, right? If it was deployed across the Yangtze and all of the large contributors to ocean pollution. Yeah.
Hans asks, of the different opportunity areas, including climate, industrial, ag, prosumer, et cetera, where are you seeing the most activity? And I'll add, I think I know the answer. What are you most excited about?
Oh, climate. I think they're all equally growing, Hans, at the same level because there's just so many people innovative in all these different spaces. But if you combine the way I did climate to include battery, EV, clean energy, it's probably where in the last 15 months we've seen the fastest growth in investment funding. Whereas I'd say previous to our current presidential administration, investment in climate technologies was tougher to come across. And it seems that it's just accelerated in the last 18 months for sure.
And then Sid asks, Sid Mana or Mana, sorry if I got that wrong. How is the future of VR and AR going to affect?
That's a great question. So we actually do a lot of work in the VR AR space.
Yep.
Some around controllers, some around the headset, some around other haptic feedback devices. The trends that we would see in the AR VR space would be the accessories to the metaverse, let's say. I'm always reluctant to use that term, but if you think about haptic feedback for your hands to simulate the holding of a phone or a glass of water, all sorts of different things, right? There's obviously peer-to-peer applications that people are exploring, right? And we've seen some of that that's come through as well. But I think that's where we'll see is the increased blend of augmented reality VR, but also having that haptic feedback. I don't know if anyone's done VR and then tried to reach for your beverage. Why, you either have to lift your goggles off or have some other, way to do it. If you could blend those two, think of a beer koozie with infrared sensors on it that your Oculus could then just thing. Now it's in real time and you can see your beer on your counter or something like that. So I just made that up. So if Brady, you can take that.
I love my face lit up. That's great. I use VR twice a year, but I'd love to be able to see my beer when I do it.
That's it's strangely one of the largest complaints with people that are active VR users is that being able to grab your drink or you're wearing this thing, you're playing a game, you pause it, you either take it off, and it has to kind of not reboot, but turn it back on. Anyway, so it's a thing.
Yeah, well, I totally get that because the whole thing about VR is it is so immersive and it tricks your brain and you're in it. And then having to take it off to take a sip of water just ruins the whole.
Right, and if you're using it in the metaverse sense, where you're hanging out with your friends, watching a movie or something in the metaverse, I guess, you could all have your virtual, soda, I suppose.
So we've talked a lot about batteries, and I'm curious what innovations are happening that you're seeing in batteries. Are there any new chemistries that are coming online specifically?
I'm just making sure that my director of electrical engineering wasn't behind me.
to tell you how wrong you are with your next answer.
Yeah, I'm the wrong person to answer this question. But in the conversations that we're having internally, there's no mass producible new chemistry for batteries that changes its linear power to, it's a linear curve. You can't like battery life is, you can get more out of a battery by having really efficient firmware and device, but it's more power is bigger battery. It just scales that direction, right? So,
but what about even just getting away from lithium? I mean, we talk about scarcity also. The inputs are becoming more and more scarce. I could see people changing or trying to change chemistries to increase
it's
power or
probably at every major research university, there's someone trying to figure that out.
Okay.
Yeah, absolutely. Because it is becoming more scarce and will so in our lifetime, right?
Yeah. Let's see. Are you seeing stuff happening in the metaverse? I mean, you talked about the VR stuff. Are more folks coming online? Should we be thinking about metaverse differently than just VR goggles? And
yeah, I'm the wrong person to ask. We're all very much Luddites here. Strangely, like we make, we did a list the other day, and everyone at this company, if combined from previous lives and currently here, have touched every single wearable that's ever been made, except for I think Fitbit was the only one that we couldn't pinpoint working on in some way. But none of us own a smartwatch or anything like that, which is really funny. So yeah, I mean, we have a VR system at the office to play like a video game here and there, because we worked with, one of the systems that do that, right? But I don't know. I personally don't want to be in a meeting with a headset on. It's for longer than 10 minutes, right? And even then, I'd prefer to see the real person than an avatar, I guess. But that's just me. I'm sure for medical applications, there could be a lot of growth in the AR VR space. And if you think about design and architecture, the ability to manipulate objects in a VR space, right? So I think for like anything, it starts off as sort of a novelty, not a novelty, but an interesting technology, and then it gets adopted by industry. AR is a great example of it, where a technician can walk up to a panel, and with AR glasses, the panel is completely labeled with what inputs and what outputs need to be adjusted, et cetera, right? Without all the gauges needing to actually be in the panel, right? So you can see things like that, right?
Yeah, there was a company called Stream, STREEM, I think, that was doing an augmented reality thing kind of along those lines. Okay. So you mentioned that your team is distributed. I know we were talking about it before this event kicked off, that you've got, somebody at Cape Cod and somebody everywhere. Do you have any tips and tricks for our teams who are distributed? It seems like maybe being a distributed team that's focused on marketing would be pretty straightforward, but being a distributed product team.
I think any team that has to collaborate, it's not as straightforward, right? I mean, hardware is a physical thing, but just brainstorming. There was an article the other day that said that people were better at making or just as good at making decisions in a virtual environment, or let's say, a call like this, right? But brainstorming was less efficient. They came up with less ideas in a virtual call than they did if they were in person. And we've experienced that as well. I was part of an anthology book recently that was published by Harvard Business Review. And one of the things that we discovered the summer of 2020 is that, after about a month or two, we started to see this slow ramp down on the speed at communication response within our teams, right? Because we were still using the mindset that we had prior to COVID, which is like at 5 p.m., you don't bug your colleagues, you don't text them or call them, right? It's always like you tap them on the shoulder if you're in the office and have a quick little conversation. But we teams have lost that in after the shutdown, right? So we just sat down and told everybody, like, it's a different world. If someone doesn't respond to you on Slack or email within the time frame that unblocks you from doing your job, pick up the phone and call them. Right? It's just like you walking over their desk and say, do you have a second? It's the fastest way to unblock things. And if you block someone for a day's worth of work, that client's happy because that's a day, there's not a day-to-day slip when you do things like that. So we had to really talk about that as a team, as a way to, we've always been a distributed team. Prior to COVID, we have an office in San Francisco. We're more distributed now, Portland, Spokane, New Zealand, currently Cape Cod, Vancouver, right? But we're still holding to the, pick up the phone and call, right? You just have to do that. And people can set their own boundaries and say, well, after 6 p.m., like I really am, not available. But for the most part, everyone's pretty collaborative and wants to just unblock someone as fast as possible.
Yeah, that's my old man thing, is I love the phone. Yeah, if you don't, and the nice thing is you don't have to pick it up. You're not really bugging anybody if they don't pick up the phone.
Yep.
Well, I think we should probably wrap it up. I'm showing 1 o'clock here. Aaron, thank you. This was great. You are now the second Igor Institute speaker in this series. Ryan,
I did it. Yeah.
As everybody knows, was I think one of my very first speakers, and one of the first people I met when I was getting into the hardware ecosystem here. So really appreciate the time. This was fantastic. As a reminder to everybody else, next week, Friday at noon, will be our last hardware fundamentals of the season. And we'll have Jim Brismovitz, who will be presenting 5G fundamentals for entrepreneurs. So we're going to dig a little bit deeper into what 5G means for all of us in the hardware space and the software space as well. So sign up for that, and we will see you all next week. Have a good weekend. Thanks for coming.